Hello everyone. Now we need to continue our lesson. The lesson for the Form 5 today is 2.2. There's current and voltage. So from here what we need to learn for this one topic, we got three things: current, voltage, another one is resistance. Okay, so now we need to introduction. So make sure you take out your notes. We're going to see all the definition here. Okay, first one we introduce for the current first. I think before that I also show about the current formula. Okay, repeat again. So current formula, the first one they say rate of flow of charge. So everybody know rate of means the formula must over the time. So now what over the time? There's a charge. So from here, current formula is I equal Q over T. Remember the Q is a charge. The unit is a coulomb. Okay, so from here we need to know the SI unit. For the current, there's a unit we write ampere. Okay, if you don't want to write ampere, you can see about the coulomb over the second. So this one is a unit for the current. Okay, number two. Number two, they say the measurement. How we go to measure the current? So we measure the current by using ammeter. Okay, ammeter. Okay, how we go to connect the ammeter? So from here, the connection for the ammeter in the circuit, we connected by series. Okay, connected by series. Okay, example, this one is a diagram for the series. Okay, diagram for the schematic. So this one is a battery. Okay, so this one is an ammeter. So the ammeter series means the wire straightforward, you join the ammeter. Okay, after that, the wire straightforward to join about the bulb. Okay, join the bulb. After the wire, join back to the negative terminal. So this whole circuit, we call it series circuit. So the ammeter, they join with the series circuit. Okay, so I show you the diagram for the ammeter and also the series circuit. Okay, now after the current, then we need to see is a potential difference. Okay, for example here. Okay, for example here, they show you all the meaning for the potential difference. Okay, so now we go and see what means of a potential difference. Another way, you can say there's a voltage. Okay, normally we didn't say potential difference, we say how many volt. That one is a voltage. So from here, first one potential difference. Okay, the symbol is a capital V, potential difference. Okay, now definition. Okay, let's see the definition. Number 3 is a definition. 1 and 2 just explain. Okay, now we're going to see number 1. An electric circuit must have cell or some source of the electrical energy if there's to be the current. Okay, so that means here the meaning is every circuit you must have the battery or you say power supply. So that one is a source. So from here, this one source is produce the current. If you don't have the voltage, that means you cannot produce the current. Okay, so they say if there was some of the electric energy, so if there is to be the current, if got voltage, after that you got energy. Energy for what? Energy, they want to let the charge to move. When the charge to move, then you get the current. Then the current flow through the circuit. Then after that, you can function the whole circuit. Okay, number 2, the energy to move the electron, or you say to produce a current, we call what? Voltage, or you say potential difference. So that's why the battery actually was a function. The battery, when you just put it, okay, they produce the energy, electrical energy. After that, electrical energy was a function. They move what? Move the charge, electron. Okay, when they move the charge start to flow. Okay, when the charge start to flow means what? The current is produced in the circuit, then baru can be function. So that means the conclusion is you must have the voltage, then you must have the charge to move. Number 3, current flow. Then the circuit, then we can use. Okay, last one, number 3. Number 3 is a definition already. The potential difference defined as work done. Okay, related with the work because you want to move the charge to move. Okay, work done when 1 coulomb of the charge move between 2 points in the electric field. Okay, example, I draw the diagram here. Okay, so this point A to point B. Okay, point A to point B, we got one of the resistor. Okay, resistor. So from here, you need to do the work. Let the charge to move from A to B. So this one charge is what? how to move the charge, you must have the potential difference to help the charge to move. So from here, the definition for the potential difference is work done. Okay, work done, you are using the work to move 1 coulomb of the charge. 1 coulomb of the charge move from point A to point B. Or you say from one point to another point. Then after that, this one is a definition for the potential difference. Okay, I show you the diagram about the definition for the potential difference. So that means you no need to memorize words by words. You can refer the diagram. After that, you go and create your definition. Okay, now we're going to see the formula. Okay, let's see the formula. Just now the definition, they say work done to move the charge. So that means they got 2 physical quantity, what you mentioned just now. Okay, work done. Okay, move the charge over the charge. So you can say W over Q. You also can say E over Q. E is what? Electrical energy. So from here, this one is a formula for the potential difference. Okay, after we show the formula, we must know the unit lah. Unit normally the voltage, or you say potential difference, we're using volt. How many volt? So the volt, there's a small v, small v or capital V? Small v is wrong. Small v stands for velocity, remember? So we're using capital V, 9 volt. Okay, you buy the battery, you can see 1.5 volt. Then what is the potential difference? Okay, another one they say about how the connection. Ammeter, we know the connection is a series. Now we need to know potential difference. That's using what to measure? Voltmeter. Just now is ammeter, now it's a voltmeter. So ammeter, we just symbol, circle, then you label A. Okay, for the voltmeter, also circle, but you label there's a V. Okay, this one is a voltmeter. Connection, when in the circuit, they must connect parallel. Okay, parallel with certain thing you want to measure. Example, I want to measure this one resistor. So that means they put the voltmeter parallel with this one resistor, so we can measure this one voltmeter is how many. The voltage is how many. So from here, when I join the whole circuit, I want to measure this one resistor, the volt is how many. So that means whole thing is the same like the before that. Now you want to measure the voltage, so you put the voltmeter parallel with the certain resistor you want to measure. Okay, so this one is a characteristic for the ammeter and also voltmeter. Ammeter series, voltmeter you need to put parallel. Parallel means you need to extend 2 wires or more, go to connection. Okay, so this one is a introduction for the current and also resistance. So formula 2 got 2 only. First one current, the second one is a potential difference. Okay, so go through your notes. We got 2 example questions. We need to do it. So now you can try to do the example 1, example 2. Okay, so I clear the board first. Okay, come, let's see the example 1. You read the question already, is it? Okay, they said the battery. There's a switch on for a few moments. Now the time is, in that time there's a 40 coulomb pass through the battery. So we write the info. Okay, example 1. Okay, go water. Okay, example 1. 40 coulomb of the charge. So Q equal 40. Okay, then we continue the battery and the carry of the 240 joule of the electrical energy. So number 2, we know there's a work done. 240 joule. So it's a charge. Okay, then we're going to see the what is the potential difference across the battery. Okay, up about the V. V is how many? So this one is a straightforward question. We apply V equal W over Q. So the answer should be 6 volt. Okay, finish. Then the example 2. Example 2, okay, we see here example 2. Okay, example 2, the info, current, 8 ampere. Okay, the next one flowing through the electric heater for the 50 minutes. Time taken, 50 minutes convert to the 3000. Second, 300. 3000. Okay, 3000. Okay, now we're going to see the following one. Okay, energy. Then given the energy, there's a work done. 576 times 10 power of 6 joule. Okay. So now we continue with the question. What they want? First one A, they want to calculate total charge that circulate through the heater. They want to find the charge. Q is how many? Okay. For the B what they want? B they want potential difference. Okay. From here we need to find out how to find the Q. Okay, we got formula this one. We can find the Q. The problem is we do know the V. We do know the V, so that means I cannot using this formula. So better I using the current formula. I find the Q first. Okay, current formula we find the Q. After that apply the Q from here, then we can find the V. So we do now. Okay, current. Current equal Q over T. So that means the current is 8. Q we do know. The time taken is 3000. So I get the Q first. Okay, Q the answer should be 2.4 times 10 power of 0. 1, 2, 3, 4. 4. Power of 4 coulomb. Okay, I find the Q already. Now I apply V. Okay, V equal W. 5.76 times 10 power of 6 over Q. 2.4 times 10 power of 4. Okay, so final answer is 240. Okay, so this one is a 2 question to find the potential difference. Okay, so we apply 2 lah. Sometimes we using current formula, sometimes we need to combine because 2 formula also got Q, so they can combine and use. Okay, so this one is an introduction for the 2 physical quantity, the simple one. Okay, these 2 simple physical quantity, we need to create one of the experiment. This one experiment, we call it Ohm's law. This one Ohm's law, we need to do the PKS, okay, during your class, because it's still including. Inside one of the experiment, there's a category A. They got hypothesis, you need to plot the graph. So from here, I need to introduce first the experiment. So this one, when your school reopens, so we need to do lah. Okay, now we go to read first. Okay, they want to find the relationship between the potential difference and also the current. Okay, for the metal conductor. So we're using the conductor. So this one experiment, we call it Ohm's law. Okay, Ohm's law. Okay, Ohm's law. So Ohm's law sure got definition. Okay, so from here you refer this one. Okay, let's see what's the definition. Okay, now you're going to see the Ohm's law definition. Okay, Ohm's law. The potential across, that's a V, potential difference across a metal conductor is directly to the current. So that means they give the meaning is V, okay, directly proportional with the current. So this one is what they want to mean. Okay, to the current flowing through the conductor, provide that the temperature remain constant. That means the temperature now should be constant. Okay, so this one is what definition for the Ohm's law. We cannot write by words like this, the symbol, no. We need to put the full sentence. Potential difference, okay, then when they just across the metal, then we directly proportional with the current, okay, then after that the temperature constant. So this one is a definition for the Ohm's law. Okay, if refer for the definition, we find it, the graph should be like this lah. V and T should be like this, directly proportional. Is it? So from here, this one graph is represent Ohm's law graph. Okay, Ohm's law graph. So that means when we do the experiment, 2 physical quantity, V and I. Okay, V and I and not T. This one is I. So V and I. After that, we get the result from the graph. Then we need to find the gradient. That one gradient related with the Ohm's law. Okay, so from here we go and find out the graph first. Okay, let's see the graph. V versus I. Okay, V versus I. Okay, after that, pass through the origin. Pass through the origin. So this one we can say V is directly proportional with the I. Okay, so from here, if I want to create the equation, remember the equation, y equal mx plus c. Okay, from this one graph, we don't have any c. So what we do, we just write y equal mx. Okay, so from here, the graph, there's a v equal mi. Agree? The m stand for gradient. Gradient from the graph. Okay, so now this one gradient. Okay, we got a special name, not just give the m, we got special name. Okay, so from here, the m, we call it resistance. Resistance for the resistor. So because whole circuit, example for the whole circuit. Okay, this is a battery. Then after that we got ammeter. Okay, now until this part, I put a one wire. Okay. Then after that, this one I want to measure. This one wire, the voltmeter is how many? So this one is an example for the circuit. Okay, we got switch. Okay, you can put switch. Okay, so from here, this one is a resistor. Okay, because the wire, every wire got resistor. So after that, this one is a voltmeter. So from here, we need to find out resistor. This one resistor, the wire, how many resistance? Okay, so the resistance means something to block the current to go. This one we call resistance. If you put more wire, means resistance is too high. Resistance too high means after that the current will want to go through. They need to using more current to overcome the resistance. Then the current can be passed through. So this one is the resistance. Okay, when we create the Ohm's law, the gradient of the V versus I, that is a resistance. Resistance for this circuit. Okay, resistance is a constant number. Example, you buy the bulb, but bulb got certain resistor. The resistance is a fixed one. You can say, oh, I want to change. You want to change, you must buy the variable. They got adjust one. Okay, adjust the brightness of the light. That one we got different resistance because you can adjust. If you buy the fixed one, the fixed battery, inside the battery got how many resistance? That one is a fixed one. Okay, so from the Ohm's law, the resistance should be the fixed one. Okay, they cannot change. Okay, now we go through to the experiment, how to explain. Okay, so from here, the experiment, they want to investigate relationship between the current and also the potential difference. For the metal conductor, we need to find the metal conductor because metal conductor can conduct electricity. Okay, let's see the hypothesis. Okay, from here, your note is don't have hypothesis. So we go to create our hypothesis. Okay, hypothesis is, okay, let's see the formula. Okay, we want to find V and I. Okay, what's the relationship V and I? Okay, V increase, the I must be increased because I told you the resistance is a constant. So now I change the formula. M I'm going to use already. M is a gradient. So from here, I straightforward put V equal Ri. R is a resistance. Okay? Then V and I, what's the relationship? Directly proportional. Okay? So you see this one graph, directly proportional, is it? So this one experiment, they want to prove. Is it V and I is a directly proportional? So your hypothesis, how to write? So we're talking about current first. We control the current by using the ammeter. So from here, when the current increase, potential difference also increase. So this one is a hypothesis. Okay, let's see the aim. Aim, there's an investigate relationship between the potential difference and also the current, okay, in a metal conductor, using the metal conductor. Okay, variable. Variable here also is empty. So that means you need to write the variable. Okay, manipulate variable, we choose there's a current. Responding variable sure is a potential difference. Okay, fixed variable. Fixed variable, you can say about length. Length of the wire. Okay, you also can say resistance of the wire. Okay, you also can say temperature of the temperature no often, just to write temperature only. Because here they say temperature constant. So we just write temperature. No need to say temperature what. Okay, so this one is a constant variable. Either you write resistance, either you write the length of the wire, either you write about temperature. So these three must be constant. Okay, now apparatus. Okay, we see the diagram what we need. First, you must have the battery. Okay, number two, you must have the ammeter. Because you want to calculate the resistance. Later they ask you to calculate the resistance, that means you must have the ammeter, you must have the voltmeter. Okay, after that, because you want to read current, you want to read about the voltage. Okay, after that, you're using the wire. Okay, this one we're using conductor wire, we're using constant wire. One of the metal wire name, constant wire. Or you say you're using the copper wire, up to you. Okay, after that, switch. Okay, if you do want to mention the battery and switch, you straightforward to mention power supply. Okay, so from here they got label for you. Okay, ammeter, voltmeter, rheostat. Okay, this one is an important thing. Rheostat, how to draw the rheostat. Rheostat also must be series. Okay, rheostat just like this. This one is a rheostat. Okay, symbol for the rheostat. Okay, rheostat is a one thing that can adjust the current. Okay, how to adjust the current? So when I just adjust the rheostat, you see the ammeter, the needle will moving. So suppose I not adjust the current, I adjust the rheostat. I adjust the resistance. Okay, when I adjust the resistance, so now voltage, they come here is the same, 6 volt. Okay, 6 volt, they come here should be the same. Okay, now I. Okay, I adjust the rheostat resistance. When I adjust this one R, that means this one I should be changes. Okay, so when I put here, so there was 6 volt, when I come here, okay, I adjust, I make it shorter, I make it longer, so that means your current, they show in the ammeter, the needle should be deflected at the different readings. So this one is a rheostat. Because just now I mentioned, manipulate variable is a current. So how to control my current? So I'm using rheostat. Okay, so you must mention the rheostat, that's important. Okay, the next is a constant wire, this one wire. Okay, the next is a connection wire. Connection wire is the outside wire. Okay, the outside wire we call connection wire. Okay, the next one you got dry cell. You want the dry cell and switch, then you put power supply. Okay, that one is the least apparatus. Okay, after that you must drawing. Okay, drawing follow here. Follow here, they got simple drawing. This one we call schematic circuit. Okay, you must draw properly. Okay, although you do not know how to draw properly, you just label. Okay, you label and the connection must be correct. Ammeter must be series, then the voltmeter must be parallel. Okay, so now I show you the diagram and also the procedure. So you refer there. Okay, now you see the procedure first. Okay, turn on the switch. Okay, before you turn on, you say set up. Okay, after that you say turn on the switch. This one you must mention. You do want turn on, you say switch on. Switch on the power supply. Okay, then you adjust the rheostat until the ammeter reads the reading 0.2. So you are manipulating variable is a current. So you must control the current first. So from here you adjust the rheostat. You must say adjust the rheostat. You cannot say switch on then the current is how many. If you never adjust the rheostat, current is cannot show. So from here you adjust, then you show the current is 0.2 ampere. Okay, now number 2. Now you need to read the reading. Read the value of the potential difference from where? From the voltmeter. Okay, from the voltmeter, after that you record the readings. Okay, record the readings. Okay, after that you just repeat. So because 1, 2 actually we finish one set already. So you repeat lah. Repeat to adjust your rheostat until the current now is a 0.3, 0.4, 0.5 and 0.6. So we finish one of the experiment. So just simple only. The procedure just 4 or 3 sentences like this only. After that, okay, okay. So now you finish. Okay, finish and see all the procedure. So now after that is a tablet data lah. So tablet data you need to write the symbol and also the unit. Then you fill in what is the current. Then the V you just empty and analyzing the data. So analyzing the data, please don't block. So you know the Ohm's law how to draw, but you don't plot. You just V versus current, then you don't plot. Empty it. So this one is an Ohm's law experiment. Okay, now, okay, finish one of the experiment, then we need to go through the next one. We need to introduction for the resistance. Okay, so wait. Okay, now we continue with the bottom one. The bottom one is ohmic conductor and also the non-ohmic conductor. Now we go and see what is the ohmic, what is the non-ohmic. So the conductor will obey the Ohm's law. Remember Ohm's law? How we know they want to obey Ohm's law or not? You see the graph. Okay, when they just show you the graph is a V versus current. Then they pass through the origin, then we understood. This one is obey Ohm's law. Yes or no? So when they obey Ohm's law, okay, I understood. This one is a ohmic conductor. Okay, ohmic conductor. Example normally is iron, steel, that or nichrome, copper. That one is an ohmic conductor. So normally when they do the experiment, they're using this kind of the wire. You can see the graph when they plot, they should be directly proportional. Okay, now we got non-ohmic conductor. So you don't need to memorize what is the ohmic, what's the non-ohmic. Non-ohmic, when they just show the graph, they're not directly proportional, so that one we call non-ohmic. Example. Okay, here I got a diagram to show you V versus I. They get it, there's a curve up. And this one is a bulb. Bulb inside is using what? They're using the filament. Filament inside we're using the tungsten. So the tungsten is not ohmic conductor. So that's why they get the graph is up. We also got resistance, but the resistance is not constant. Okay, so that one is a non-ohmic conductor. Okay, after that we also got, you see the diagram, V versus T, V versus I. There is a straight after that like this. This one is a thermistor. Thermistor is one of the component. They want to control about the resistance. So they can high, they can small resistance, depend for the situation, thermistor. Okay, depend for the heat. When the temperature become high, they changes. When the temperature become cool, they go to changes. So that one is a thermistor. That means the resistance is not constant one. Okay, the next one, we got another one. There's a semiconductor. Okay, semiconductor sometime. Okay, there's a I versus V. Like this. Up. Then after that, flat, then up. So that means this one is another graph. Another graph that not pass through the origin. So this one we also can say there's a non-ohmic conductor. Okay, I'll show you some of the graph. There's a non-ohmic conductor. Okay, you can see the diagram. We got 4 diagrams there. They show the graph is not passed through the origin. So that one is a non-ohmic conductor. Okay. Now we go to introduction for the resistance. Okay, so that's why I said this topic we got 3 physical quantity. Current, potential difference. Now is a turn for the resistance. Okay, we go through to see resistance. Resistance is a ratio. So the first one, definition. Ratio for who? For the potential difference to the current. So just now we find it, V equal Ri, is it? So the R should be V over I. So this one is a definition for resistance. You cannot say, oh, V over I. That one not definition. The definition is a ratio of potential difference to what? To the current. So that one is a resistance. Okay, resistance. We need to know what's the unit. Okay, what's the unit for the resistance? Okay, through the formula, we can create the formula is a volt over ampere. This one you can write about the resistance unit. Another one I think you learned before, there's a kH. So resistance, the unit should be ohm. Okay, just now I said Ohm's law. Or you write the symbol. Okay, this one we call ohm. Okay, so from here, this one is a resistance formula, and also what's the unit, SI unit for the resistance. Okay, now, so from here, SI unit finished. Now we go and see gradient. Okay, through this formula, okay, from here they draw the graph. Okay, V versus I. when they pass through the origin, okay, this one is represented by the resistance. Gradient equal to resistance when VI graph. Okay, the next one, if I terbalik the graph. Okay, what means of terbalik the graph? Terbalik the graph means I reverse the symbol. Okay, when I reverse the symbol, many of you, they do the mistake. Okay, they said, okay, now pass through origin, then the radiant is a resistance. No, you must still be careful. This one when become I, this one become V. The graph still like this. Okay, then they call you to find resistance. Is it the resistance still gradient? Sorry, no, you must be careful. Okay, so from here when I find the gradient, okay, example, my gradient is a 5. I get 5. So the question asks you, okay, resistance is how many? So your resistance is become 1 over gradient. Okay, there's a 1 over 5. Okay, remember, if for this one, gradient equal 5, so your R must be equal 5. Okay, so you must see, be careful. Okay, what versus to what? Because some question memang they want to trick you. So some student that's not specific to see the question, so then you lost the marks because of your careless. Okay, so from here I want to explain a little bit. Okay, for the metal conductor, if the temperature and the other physical properties remain unchanged, the resistance of the conductor not depends on the current and also potential difference. So that means if the temperature there's a constant, there's nothing to be changed, the method is still the same. So that means the resistance actually there's not affected by the current and also not affected by the potential difference. I told you the resistance is a constant. They never change because of the voltage, because of the current. Okay? So now we're going to see the following. What will affect the resistance? Current and voltage, no. Then we got others lah. Sure got others will affect for the resistance. Okay, now the following. Following we got 4 factor. 4 factor will changes the resistance reading. Okay, so these 4 factor here, 2 will come up for the experiment. Okay, because we got factor. We sure need to do the experiment. We want to prove. Okay, when this one increase, then that one how. So we got 2 always will come out lah. Because another 2 is very hard to design the experiment, so they never do that. So from here we're going to see the first 2 factor always to come out what? Okay, then we're going to see the first one, factor that affect the resistance. First one is a light. Light. Okay, conductor, that means the wire, how long? Okay, this one is a light. So that means the wire, copper wire, I know the resistance should be constant. But the problem is, if you take longer, the resistance will be affected. Okay, that means the size changes of the wire, the resistance will be changes. So from here, we're going to see the explain here. For the conductor, for the same material, make sure the material should be the same. Okay, the cross-sectional area and the resistance is directly to its length. 2 things is constant. 1 material, number 2 is a cross-sectional area. Example, this one's a wire. Okay, wire. Okay, copper wire. Okay, material is the same. Okay, another one is a cross-sectional area means diameter. The area. Okay, the whole diameter and also the area of the whole wire is the same, never changes. Okay, so the resistance will directly proportional with the length. So you take longer, mean the resistance should be higher. So this one is one of the factor will affect the resistance. So if you take longer, lagi resistance become bigger lah. So from here example, okay. So if I take one of the wire, like this, okay, this one we call R. So if I take double, this one become 2R. So I take longer some more, this one we call 3R. Okay, so directly proportional. Okay, so from here, this has the first factor. Then we go to the second factor. Okay, B. Second factor is a B. There's a cross-sectional area. Just now I told you. The whole wire, the area. That means normally we think about the surface. Okay, this one is a wire, is it? This one is a wire. Okay, this one we call cross-sectional area. Okay, cross-sectional area. Okay, so now this one is a second factor. They say for the conductor, same material. Okay, now the material is the same. Then they're talking about length also same. So I draw it. Sectional area. Okay, this one is a wire. Okay, cross-sectional wire is this surface. Okay, example, this one is A lah. Okay, the area is 1A. So from here they say when the material is the same, the length also constant, so resistance is inversely proportional with the cross-sectional area. Okay, mean like this. If I draw another one, okay, this one is a 2A. Okay, then I draw another third one, 3A. Okay, now what you think about the resistance? Okay, assume O is the same length. Okay, the resistance will become more or become less? Okay, the answer is become less. Okay, if this one is a R, this one must be 1 over 2R. This one must be 1 over 3R. Okay, so this one is another factor that affected the resistance. Okay, so this one is an example diagram to show you how to understand. Okay, so from here we need to draw the graph for the inversely proportional. Directly proportional we know lah, length and resistance. So if I put the length I control, so resistance is here. Okay, I find it directly proportional. So if for the inversely proportional for the area, so when I draw the graph, okay, I control the area. So this one's the resistance. Your graph should be inversely proportional. So if I want to plot become directly, so you need to change this R 1 over A. So become directly proportional. So this one is a 2 factor that will come out for the experiment. Because they're easy to control. Experiment first one we control the length only. So you adjust the wire lah, 2 cm, 3 cm, 4 cm. So another one thickness. You control the thickness of the wire lah. Make the wire, use the first wire, thinner one, the second one is a thicker, then continue. So this one they can create the formula. Okay, for the cross-sectional area, we got something to discuss more compared to the light. Okay, now I go to clean first. Okay, now we go through the Ohm's law graph again. Okay, Ohm's law. Okay, remember the graph like this. V versus I, after that pass through origin. Okay, now example I try. I'm using the different diameter. Okay, different diameter of the wire. Then after that I go and see the result. Okay, I get it A, B and C. Okay, you tell me which one the diameter should be higher. That means the cross-sectional area become higher. So you're going to see the graph lah. Okay, we refer the gradient. We find the resistance first. Okay, this one resistance should be the highest. Yes or no? So RA resistance is the highest. Then RC should be the lowest. Agree or not? So if RA should be the highest, mean this one wire is thicker or thinner? The answer is thinner. You are the thin wire. When the wire is a thin, your resistance should be the highest. When the wire become thicker, is it at the balik? Sorry ya, at the balik. So I repeat again the explanation. Okay, so refer here. Okay, when the thicker wire, the resistance should be the lowest. Okay, this one. Sorry ya, this one. Is it wrong? Okay. No, we don't care about that. We continue first. Okay, resistance for A memang is highest. This one should be the lowest. Okay, so which one become thicker? We're going to see here. So this one highest R, but the area should be the smallest. So this one highest R, is it? Resistance higher. So this one is a thinner one. That means your area should be the lowest. You are the thin one. So this one, the wire should be the thicker one. Okay, because both is inversely proportional. Okay, we refer the graph, then we know already which one should be the thicker, which one should be the thinner. Okay, some question, they never talking about thinner and also the thicker. They're using the word SWG. Okay, SWG, they're just one of the code. The code for what? Code for the thickness of the wire. So example, you need to know the full name. The full name we call standard wire gauge. Okay, standard wire gauge. So from here of the conductor wire, the number of the standard wire gauge, that's a higher, mean the thickness of the wire is decreases. Okay, example. Now I do the label. Okay, SWG. Okay, SWG. This one is 32. Okay, this one is 20. This one is 12. Okay, I simply give the number because SWG is a standard one. We don't know. So I just want to give you the relationship. So now, RA, the resistance should be the highest. Okay, resistance highest means the cross-sectional area become the lowest. They're the thinner one. Okay, now you see SWG. SWG is standard wire gauge. Okay, you see the number. When the number become bigger, SWG, the number is higher. What's the meaning? Number higher means thinner. Diameter small. Okay, diameter small. You don't misunderstand with the number. Oh, number higher than thicker. No. Number higher means there's a thinner. Resistance is higher. So we can say SWG directly proportional with resistance. Okay, SWG, the number is directly proportional with the resistance. So from here they say, when you find the SWG become higher, thickness of the wire should be decreases. So this one should be the decreases. This one should be the thicker. Okay, when you see the number become smaller. Okay, so from here, when the question they come up for the experiment, okay, relationship between the resistance and also the thickness of the wire. Okay, please don't write SWG how many, because we do know the standard code. This one you need to go to workshop, they go to ask the uncle. SWG 32 got or not? What number you got? Because we all don't know, we simply go to hantam, cannot. So you just say you want to using how many diameter is okay. Don't using the word SWG. This one just one of the relationship. Okay, I just want to tell you the code of the wire. They're using the standard wire gauge to measure. Okay, so this one is the second of the factor. Okay, now we go to third factor. The third factor is the type of the material. So now, cross-section area constant, length also constant. Now we're using different type of the wire. So your material different, that means the resistance also be changes. Example, we got good conductor. We got poor conductor. That one is the resistance factor. Okay, now you're going to see the following. Okay, the following diagram is type material. So third factor, type material of material. Okay, you see the graph. Okay, now they got four different of the material. Nichrome, constantan, copper, and silver. Okay, so we just label nichrome, constantan, copper, and also silver. Okay, we just find about the gradient if you want to test the resistance. So the highest resistance should be the nichrome. So which one is a good conductor? Good conductor sure is a silver. Okay, good conductor. Okay, because the gradient is less, resistance less, means current high. Agree? Follow the formula. V equal IR. V you provide from the battery constant, not affected. If the resistance high, that means the current they pass through become low. If the resistance become low, that means now the current they pass through the silver is very high. So this one we call it silver is a good heat conductor. Then the nichrome should be the poor heat conductor. Or you can say there's a good electricity conductor. This one's a bad one. Okay, so we just refer the graph. Then this all is an ohmic conductor because they obey the Ohm's law, pass through the origin. Okay, next we go to explain example for never pass through the origin. Okay, for the good conductor materials such as the silver, okay, and the copper, not copper, copper. Copper have the low resistance. These two is a low resistance. So for the good insulating, example for the rubber and also for the wood, that one is a high resistance. Sure, that one cannot conduct electricity because the resistance too high already, the electron cannot move. So that one we call it insulator. Okay, the last one factor, that's a temperature. Okay, temperature also will affect the resistance. Okay, refer here the graph. Okay, now the graph is a resistance versus temperature. Okay, resistance versus temperature. Okay, so from here the first one they show alloy. Okay, you see what's an alloy? You learn about chemistry, I think you know what is an alloy. I also do know what is an alloy. Okay, here you got example what is an alloy. Okay, read it here. For the alloy such as a constant wire, nichrome, the temperature is not affected the resistance. So that means you're using the nichrome, you're using the constant, you go to heat the wire. Actually, they never changes about the resistance. They're not affected. Okay, number 2, we show about the metal conductor. Metal conductor, from here metal conductor, the example there's a copper, iron. These all the resistance will be affected by temperature. If you go to heat the wire, okay, you heat the copper wire, then the resistance for the wire should be changes. Okay, how to change? Temperature increase, the R should be increases. And the last one is a semiconductor. Okay, semiconductor, I think you know, is it? You learn about chemistry, the table. The semiconductor example, here we got silicon and also germanium. Okay, this one is a resistance decreases when the temperature increase. So when the temperature increase, you see the resistance drop, and drop. Okay, means what? Resistance drop is good or bad? That's a good. Current can go what? Is it? So from here, that means when the semiconductor, you want the current to pass through the semiconductor faster, you need to heat. Okay, you make the temperature higher, then the resistance drop. Okay, now the semiconductor can conduct electricity. So that one is a different thing. The 3 different metal, you find it, the result is a different. Alloy, metal, and the last one is a semiconductor. This one will be affected by the temperature. Okay, so this one is the last for the factor. So that's why I told you why we cannot using material, why we cannot using the temperature for the do the PKS experiment. Reason, first one, we don't have so many wire. We just got one type, either constant, either copper, because expensive. You want to buy so many type. Okay, another one is a temperature. How we go to heat the wire? That's a dangerous experiment. So we never using to heat the wire. So we normally do the experiment is the first one, the length. Number 2 is a cross-sectional area. Okay, so hope you can read the procedure, how to create the experiment for these 2 factors. Okay, so now I want to show the last experiment. That's the first one, that's the length only. The cross-sectional area you can create by yourself. All the things should be the same, you just change about the responding variable. Okay, then we're going to see the second experiment, the length. Okay, investigate relationship between the length and also the resistance. Okay, length and resistance. Okay, so from here, hypothesis. So what we control? We control the length or control resistance. Normally we control is the length. We can measure. So from here, your hypothesis is, okay, follow just now, length and also the resistance. The relationship is directly proportional. So from here, you write the hypothesis first. Okay, as the length of the metal conductor increase, so resistance also increase. Okay, this one is a hypothesis. Okay, aim same like just now lah. We want to investigate between the relationship of the resistance and also the length of the conductor wire. So we're using the metal conductor should be the Ohm's law one, the constant wire. We're using the ohmic conductor. Okay, now variable. Variable we got 3. Manipulate sure is the length of the wire. Responding variable should be the resistance. Okay, now fix. Length become physical quantity for the manipulate variable. So the rest should be constant variable. You can write about cross-sectional area. You can write about the temperature. You can write about type of material, okay, of the wire. So this one is a 3 of the constant variable. Okay, now apparatus. Okay, apparatus 1 is an important thing. Okay, you need to put in. That's what? Meter rule. Because there's a line. You want to control the line. So meter rule must in. So remember, so from here I show you the diagram. Okay, see what is the important thing. Okay, you can see the diagram. They got the list of the apparatus. Material, they got ammeter, voltmeter. Must have ammeter and voltmeter. Reason why? Because you want to measure resistance. We don't have any the instrument to measure the resistance. Okay, they just got voltmeter, ammeter. After that, you're using the formula. Then we got constant wire, connection wire, dry cell. Dry cell, you just convert, become the power supply. Must have the rheostat because you want to control. Then the last one, the important should be meter rule. Okay, now you see the diagram. Okay, you see the diagram. Okay, the diagram same like just now what I draw. They got rheostat, constant wire, voltmeter is parallel, then they got battery, they got switch, ammeter. Ammeter is a series. Okay, let's see the procedure. The procedure is, the first one you say the setup. Okay, number 2, you need to mention the length of the wire you want to use it is how many. Okay, so I show you that the procedure is there. Okay, so the length of the conductor wire is measured by a meter rule. Okay, you mention how many cm. Depend for yours. Logic number 10 cm. Don't use it 100 cm, too long already how to measure. So you're using 10 cm. Okay, the next one, you must say switch on. Okay, switch on your power supply. Okay, how many to add? I got highlight already. You can see there. You help me to add, adjust. After switch on, you need to adjust. Adjust what? Adjust the rheostat. Okay, adjust the rheostat until the reading of the ammeter become 0.5 ampere. Okay, now you will ask me, is it a current become manipulate variable? No. I can tell you guarantee is no. Okay, so no, why I want to put 0.5 ampere? The reason is I don't want later the ammeter reading become bigger and bigger and bigger, or smaller and smaller and smaller. So you know, okay, relationship V and I. Okay, when the V constant, then your resistance, you make it become lower. When the resistance lower, the current should be higher, is it? So if I put the length very short, the length very short means the resistance too low lah. Resistance too low, what happens for current? Current is too high, so the ammeter cannot support it. So what we need to do, we go to adjust your current, make the current always constant number. So after that you find it, the voltmeter got changes one, the voltmeter sure got changes. So I adjust the current, suppose they're not constant variable, they're also not manipulate variable, they just want to prevent the ammeter reading is overload, then the ammeter cannot function. Okay, so you need to put this sentence, adjust the rheostat until the reading of ammeter show 0.5 ampere. So every time you go to adjust the light, the ammeter you need to make it become 0.5 ampere. Okay, now you're going to see the third one. Okay, the reading of the voltmeter, now you can record it. Reading of the voltmeter, you can record it. So that means the ammeter you don't need to record lah. You just record the voltmeter. So from here you can cut the ammeter is record, cancel. You just record the voltmeter. Okay, 4. The resistance is calculate. This one must have. Okay, responding mark. This one is responding mark because you want to find out what's the resistance. You must say record voltmeter. After that you got ammeter 0.5. Then after that, you need to do calculation. So you must show the formula R equal V over I. You want to find the resistance, you show the formula. Okay, number 5. Then you say the experiment is repeated at least 4 times. Then you mention up how many. Okay? So from here they never mention, they just say the difference of the length. So better you mention. So you repeated 4 times with 20 cm, 30 cm, 40 cm and 50 cm length of the wire. So that one is a procedure for this one experiment, length and resistance. So if I want to convert become cross-sectional area, it's okay. It depends for yours only. Just you go to changes, length become cross-sectional area of the wire. Then the rest is the same. Then drawing also the same. Okay, just from here, you need to using the length of the wire you concern already, is it? You want to measure also can. You measure now the length of the wire is 10 cm. Okay, so you need to mention your cross-sectional is how many. Please logic number. Because last year the form 5, they give me the answer is how many, you know. This one is the cross-sectional area of the wire. Okay, normally we put it, there's a 2 mm. 2 mm is how many cm? 2 mm is 0.2 cm. Very small, no? 0.2 cm like this. Okay, this one we call thickness. They give me the answer is 2 meter. 2 meter of the thickness. You tell me how big your wire, how big like this. How to do experiment. So think about that. Unit you want to use. Okay, if you do one using like this, you can do like that. Okay, I'm using one wire, one number of wire. Okay, then you want to repeat. I'm using the number of the two number of wire. Means the length should be the same. First wire, then you take another wire, you put together. Then third wire, 3 wire, 4 wire, then you put together means you increase the thickness. Okay? So that one is one of the technique. If you do one, put value. First, A1. Okay? Then you repeat it, A2, A3, A4, and A5. This one is one of the technique. Because we do know how many unit logic you want to use. Please, if you want to put a unit, put a number, please think about that. We never say about the length. Now it's a thickness. Thickness must be logic. Okay, so from here you just changes about how many cross-section area you want to put, or then switch on also. After that, adjust the rheostat also. Okay, you know adjust the rheostat also same. The current must be 0.5. Then after that, record the voltmeter reading. Okay, now you also want to find the resistance. Also, R equal V over I. Then you must repeat. Repeat what? Repeat the wire, or you can say repeat the number of the wire. 2, 3, 4, and 5. If not, repeat the cross-sectional area different. That's a what? A2, A3, A4, and A5. Okay, if you want to put number, logic number. Just now you do mm, is it? 3 mm, 4 mm, 5 mm, and 6 mm. And finish. Okay? So this one is a technique. Okay? Technique, how we going to create the experiment. So all the things should be the same. Then after that we got tablet data. Then after that we got the analyzing. So that one is the second experiment. Okay? Okay, now we want to conclude the 2 experiments, what we do it, length and also cross-sectional area. Okay, we want to create another symbol. Okay, another symbol we call resistivity. Okay, the same like the symbol of rho. Remember the rho? Density. Okay, this one is a one constant number. They follow the resistance, directly proportional with the resistance. So that means if I find the object resistance is high, that means the resistivity should be the high, unless the material changes. So the material now is a constant. So I write the equation before that, R directly proportional with the length. Okay, another one is R directly proportional with the 1 over cross-sectional area. Okay, so now I want to combine these two. Okay, R directly proportional with the length over surface and the cross-sectional area. So if I want to take out the directly proportional, so R suppose equal to the 1 of the gradient. L over A. So this one gradient, there's a rho. Okay, not rho, resistivity. So from here we can create the new formula for the resistivity. Actually, there's a what's the formula? You put here in. So the resistivity is a RA. Okay, the A you put here, multiply here, over L. So this one is the resistivity of the material. Okay, so that means this one increase, this one also increase when these two become constant. Okay, resistivity, there's a directly proportional with the resistance. When the question just say the material should be the same, but you go to changes the length and changes the area, so finally resistivity should be the constant. So this one can create the formula. So later we got the question like this. Okay, so from here the resistivity, we need to find the unit lah, because they need to do the calculation. Okay, now we're going to find the unit. Okay, R is a ohm. Okay, area should be the m square. Okay, length should be the m. So we're going to cut one m. So your resistivity, the unit should be ohm meter. Ohm meter. That one is the resistivity. So directly proportional with the resistance, also directly proportional with the length lah. So this one is the final conclusion by the two factor. We get the resistivity. Okay, the following, I need to postpone to the part 2. This one is a part 1. Okay, now I want to do the 2 example question. There's example 3 and example 4. Then the rest tutorial, I also postpone to the part 2. When I finish the teaching all the superconductor, then I need to combine the resistance, the tutorial. So what we need to do, we do example 3 and 4. After that, that's your work. You do your tutorial first. Okay, you do your tutorial. After that, I show you another lesson for the tutorial lesson. Then you can check it. Okay, so now we're going to set the question 3 first. Okay, example 3, we see the question. They say the graph that show the result of the experiment determine the resistance wire. So they give you the graph is a V versus I. Okay, pass through origin. Reading is a 5. Here is a 1.2. Okay, so now the question straightforward and add resistance. Resistance means the gradient of the graph. So resistance equal 1.2 over the 5. So the answer should be 0.24 ohm. Okay, then we go to question 4. Okay, question 4, they show you 2 diagrams. Okay, 2 wire. One is a longer wire. Okay, one is a shorter one. This one is a A. Area is a A. This one should be 2A. Then after that, this one is a length. This one is a 3 length. Okay, then they say figure show the wire P of the length, that's a L. Then the cross-sectional area is a A. Then the resistance is R. Okay, this one resistance is R. Okay, next one. Another wire, there's a Q. It's a conductor of the same material is a keyword. So you help me to underline same material. Same material means one thing you should be think, resistivity. When they say same material means the resistivity for the first wire and the second wire should be the same. Okay, so now I want to apply just now formula. Okay, the next one, the length for this one wire should be 3L. This one is a P, this one is a Q. Then after that, the cross-sectional area, this one become 2A. Okay, 2A. Okay, then what is the resistance for the Q in the terms of the R? So that means your final answer don't have any exactly answer. You're just using the R to represent. Okay, so from here we need to create the equation. Okay, now you're going to see, this one is a question, what the info they tell you. Okay, same material, just now I told you, mean the resistivity should be the same. So we write here, the resistivity for the P equal resistivity for the Q. 2 wires should be the same. So now I want to create the resistivity for the P. What's the formula first? Okay, this one, the P should be equal, okay, R. Okay, because there's one R. Okay, after that there's A over the L. This one's the resistivity for the P. Okay, how about the Q? Okay, the Q is RQ. Because RQ is we do know lah. Okay, we don't put RQ, you put X. Because you don't know what's that. Then we put the X. Okay, RQ equal X. Okay, now you got how many A? 2A. Okay, after that you got 3L. This one is a resistivity for the Q. So these two should be the same. Should be equal lah. So RA over L equal X. 2A over L. 3L. Okay, now I take out the things. Okay, you find out this one and this one, we can cut it. Okay, then after that, this one the L and this one the L, we can cut it. So what you left? You left the R equal to the 2 over 3X. Okay, what you want to find? You want to find X, is it? So the X will become 3 over 2R. So X actually is what? X is a resistance for the wire Q. There's a how many? There's a 3 over 2 resistance for the first wire. Okay, so the final answer, resistance for the Q wire is 3 over 2 resistance from the P wire. So this one should be the answer. Okay, so this one is a calculation, you can refer that. This was one of the questions without using the unit, we just using the symbol, then we do the calculation. Okay, so from here we stop a while. So what you need to do, you need to complete your tutorial question. Okay, the tutorial question is do it until question number 9. You do until question number 9 because number 10 will not yet go there. So you do number 9. After that, the 11, I think no problem. You also can do it. Okay, so this one is what you need to do the homework lah. Okay, so my class is until here. So thank you for your watching. Okay, and also have a nice day. Okay, thank you everyone.